Good afternoon, everyone. I'm Bochao from Grow Resources. I'm very happy to have an opportunity to speak here with you all here as we gather in these beautiful BCA buildings. It is essential to recognize the significant role that the innovative practice and technologies in shaping the future of the construction. So today, we will further explore the usage of the robotics in construction site for DFMA installation, focusing on how this advancement can enhance the sustainability, productivity, and collaborations within our projects. So the first part will be our company overview. We are from Grow Resources. As you know, it is a subsidiary of China Construction South Pacific. We founded in 1997 as a very experienced contractor in mechanical and electrical. With all the mechanical trades almost reach the highest MIE grades. So why we adopting the robotics technologies in construction site for MIE installation? The first one is to enhance the work efficiency and qualities, as automated drilling robot ensure the constant precising and speed, allowing us to complete the works faster and in a higher quality. The second one is to create a safe working environment for our workers, as the robotic will take over the harder and repetitive drilling task. The third one is to further explore into the smart construction solutions. By embracing the automation, I think we are positioning ourselves as a forefront of innovation of the construction industry. So as you see, this is a conventional method of how we install the MIE bracket support on site. As you see, the drilling holes and anchor install actually can be done by robot automatically. So if we do it conventional way, it requires worker to work at height for hours with a heavy equipment, and this force will be repetitive, extend to their shoulders, which will have a high risk for them body fatigue, maybe the falling risk. So I think the steps could be done by robot. And why we're choosing the CSC robot D3? We actually do some research works for the market, and we do the comparison for two models of the drilling robot. This is the comparison. So you can see that for our final selection of the D3 CSC robot, for the drawing requirement is actually you just still need the conventional layout plan drawing, while another kind of system require a very high level of detail drawing from BIM with the reference point from the surveyor. So it also costs the less tolerance on site, means the structure works, it has to come with a high precision, while the D3 robot just still use a conventional tolerance level. And for the preparation works is also less than another system, because if we use another one, we need to place the total station for stationing and locating the robot, while our one just need to follow the traditional way, like marking the drilling marks by our workers. As for the function, you can see the D3 robot can actually do the drilling and anchoring at the same time, while another one, so far it can do drilling only. And last but not least, but it will also come with the deployment cost. So after the study, we find out the cost with the CSC robot is much more acceptable by our company. So actually the CSC robot 3 is actually a suitable robot for our project and our company. So this is our drilling and anchoring automatic installation robot, Drillcorpio. I think in Chinese means 天蝎钻. The detail spec is as follows. The drill size is from 5 mm to 20 mm. The depth is from 130 can reach 130 mm. And I think the anchor type, it is a flushing anchor and a sleeve anchor, which is most conventional types of the anchors can be used. An anchor size is from M8 to M16. It also covers the range for the anchor installations. For the accuracy, we test is within 3 mm. And after the fully charged, this robot can work in for 8 hours. Robot weight is not heavy, 225 kg. And the size is actually around 1.1 meter long, 0.6 meter wide, and 1.7 meter high. Means actually this robot can be easily transferred by a personal lift. As for the working height, is actually subject to the scissor lift, because this robot is actually to be used together with the scissor lift without modify the scissor lift. Means it can be suitable. It can be changed it can be changed the height if you want to make it higher. You just need to rent another scissor lift. This is the component of the robot with anchor loader, 3D camera, robotic arm, proximity sensor, dust vacuum system, and the louver for the heat rejection. The robot is actually, just like we mentioned, is a dual function robot. The first one is the drilling process. After the drilling process, the robot will automatically switch to the anchor installation process seamlessly. With the auto tilting control, this robot is able to drill and install anchor on the curved surfaces. With the dust control and the rebar detection, the robot is actually can control collect all the dust during the drilling process. Like I said, no need to modify the scissor lift. If you want to make it higher, then you just rent another one. We deployment this robot for the area around 5,000 square meters for DFMA preferred ME module installations. Our project team actually have collaborated with CSC Robot. We conduct extensive research and implementation several improvements at the construction site. Like we already test virus of the anchor bolts. Like a flash anchor and a sleeve anchor can both be done on site. All the different size of the drilling bits we also tested. Adjustment of the marking and the tracking system to make the robot much more precise. We also help them to adjust the robotic coding to make the robot arm move much more smoothly. After the training, this is what a worker need to do. First, you need to move the robot to the installation area. Second, they just need to select the program in the tablet and do the real-time checking and monitoring. And the rest of all the sequence just leave to the robot to do it. Drilling, dust collection, change anchor installation to pick up and install anchor. And after that, it lead to the complete. So the green highlight area is our robot deployment area. Some site deployment photos. You can see just one trained worker can handle the operating the video to demonstrate the drilling and anchor installation process. And after the drilling work's been done, then we install our preferred ME module. So this is the result. Okay, so what is the advantages of the deployment of the robot? Productivity, it is the first one. With the standard operations of the drilling robot, it can complete the task, reducing the construction time. And the labor usage is also reduced because in conventional ways, it would require 2 workers, 1 worker and 1 banksman to do the drilling and anchoring. And for the robot, we just need 1 operator to complete all the jobs. And no need to mention that the worker is on the ground doing all the time. There is nearly no risk for workers to get injuries. And quality control and data recording. But nothing makes perfect. There are still some areas to be improved. Like the drilling bit still need to be changed by manually. Like if you finish the drilling for M8, then you need to manually change the drill bit to M10. So you need to plan and execute the drilling anchoring the plan by the drill anchor size. And another one is because of some areas like a beam will definitely have a potential clashing risk for the robotic arm. So there are some areas still inaccessible for the robot to do the drillings. So far for this one, we still need to require manually drill and manually to install the anchor. Thanks for your attention. That's all.